All right, today we're going to do a quick review of the skills we need in order to do sum and difference identities. Okay, the first thing I'm going to do today is hand out a blank unit circle and have you fill it in. So those of you that are sitting here, hit pause while you're watching the video and fill in your unit circle. Then turn it back on, check, see how you did. Okay, all right, pause now. All right, we're back. All right, you want to practice converting from degrees to radians, which we probably won't do much today, but let's do it. Remember, you're trying to get rid of degrees, so it must be pi on top and 180 on the bottom, because your degrees are going to cross out that way. And 60 over 180 reduces to pi over 3. Okay? You multiply by pi over 180, and it reduces to pi over 4. Okay? To convert from radians to degrees, you flip it over, you put the degrees on top and pi on the bottom because you want them to cross out. 180 divided by 6 is 30. You put 180 on top, pi is on the bottom, so your pi's cross out, and you get, what is that, 115? It's right here. I know it's 3 pi over 4. 3 pi over 4. Oh, 135. There we go. See, I think in radians. I don't know how to do degrees. And our whole lesson tomorrow is going to be in radians. Mr. Harrington's notes have degrees in them. I'm going to do radians. All righty? Because that's what you need when you move on in math. All right. Mad minutes. Remember we did those? You had to use your unit circle and answer these questions quickly. All right, so the cosine of 5 pi over 3, if you don't remember, you go up to your unit circle and you find 5 pi over 3. The cosine is the x value, so that's a half. Sine of 5 pi over 4, it's in this quadrant, it's negative. Root 2 over 2, it's the y value. Tangents are a little difficult. It's right here. I know that's a 30-degree triangle, so the way I do those is if this is 30 degrees, this is 1, 2, and root 3. So my tangent's going to be 1 over root 3. Or you can rationalize it. Let's get rid of my triangle. And you get root 3 over 3. And one of them's negative, so it's negative. The sine of 3 pi over 2, you should know it's negative 1. The cosine at 0 is 1. Those you should know without looking at. Okay, the cosine of 7 pi over 4, the bottom's 4, so this has to be root 2 over 2. The question is it positive or negative? 7 pi over 4 is in the fourth quadrant, so it's positive. The sine of pi over 6 is a half. The cosine of 7 pi over 6 is negative root 3 over 2. Tangent of 4 pi over 3, it's in the third quadrant, so it's positive, and it's root 3. That's a 60-degree triangle. If it's got a 3 on the bottom, it's 60 degrees, so it's root 3, 1, 2. Okay? And the tangent here is 1, but it's in the second quadrant, so it's negative. All right? Now, if you were in class today, we're going to do 3 more of these mad minutes to practice, and then we're going to move on and do the rest of this. So if you want to do some more practice, go for it. Come to class. I'll give them to you if you want. All righty, next. We want to convert pretty angles to have a 12 in the denominators. Okay? So if I want a 12 in the denominator, you have to multiply 6 times 2, right? So you end up with 2 pi over 12. We don't want to reduce it. The goal is to have a 12 in the denominator, and you'll see in a minute why we need to do that. Okay? All right. How do I get 12 from 4? I have to multiply by 3. So I get 3 pi over 12. To get 3, you have to multiply by 4. So you get 4 pi over 12. To get here, you're going to multiply both top and bottom by 6. And this one I added because it's kind of a convenient one to have. So you have to multiply by 4. So you end up with 8 pi over 12. All right? you should know those. Or what I do when I take the quiz or test on this and I have to do sum and difference, I just write these down the side. Pi over 6 is 2 pi over 12. Pi over 4 is 3 pi over 12. Pi over 3, 4 pi over 12. Pi over 2 is 6 pi over 12. And 2 pi over 3 is 8 pi over 12. So it's on the side of my paper at all times. Because I'm going to ask you to figure out how to get 1 pi by using the pretty angles. Okay? Well, I can either do 3 minus 2 and get a 1, or 4 minus 3. So my choice is either 3 pi over 12 minus 2 pi over 12, which if you send them back to the pretty angles, that's pi over 4 minus pi over 6. Okay, my other option is to do 4 pi over 12 minus 3 pi over 12. And that's the same as pi over 3 minus pi over 4. Okay? When we do sum and difference identities, there's a difference, here's a difference. All right? And you'll make sense tomorrow when we do the assignment. Okay? All right, I got to get 5 pi over 12. So I can add 2 and 3. So 2 pi over 12 plus 3 pi over 12. So that's what? Pi over 6 plus pi over 4. Okay, so that's my sum that I'm going to use in sum and difference identities, hence why they're called sum and difference identities. Alrighty. 7 pi over 12, let's do 3 pi over 12 plus 4 pi over 12, which is pi over 4 plus pi over 3. So there's my sum that I'm going to use. Okay, let's do pink. Why not? How do I get 11? Well, that's where this one comes in. I can do 8 pi over 12 plus 3 pi. We'll just erase that and make it pretty, thanks. Plus 3 pi over 12. So that's 2 pi over 3 plus pi over 4. And there's my sum to use for sum and difference identities. Okay? All right, this is a quick review. When you multiply radicals, you multiply the stuff underneath, and this gives you the square root of 6. When you add them, you can't add them because they're not the same. Okay? Just a little fresher reminder there. Okay, so tomorrow when we do sum and difference identities, you'll have the skills needed to be successful.